Hello everyone, and welcome to this webinar on concrete structures analysis and design using CYPE. We're going to get started in about 3 minutes. If you guys could just confirm with me the audio quality on your side, and if you guys can hear it through the chat feature or the questions feature. Thank you. If you guys can just confirm the audio quality, that would be great. Thank you. Thank you, Lamia. Appreciate that. Daniel, can you confirm the quality now? I've just turned it on. Daniel, if you could confirm, thanks. Okay, cool. All right, guys, let's get started. This is a webinar, as I said, on concrete structures analysis and design using CYPE, using our CYPE solution, which is also incorporated in the BIM workflow. So we'll just touch on that initially, a little bit about the workflow and how we like to do things here. Initially, this diagram here gives a great representation of the sort of best practice methodology that we like to adopt. So initially we'd start off with the physical 3D model. That physical 3D model can be generated through our own software called IFC Builder, where we basically just create an architectural model in IFC format. Or also we have different plugins to bring in your models from various other programs, Revit, Allplan, etc., etc. So we can bring those architectural models into our workflow and make them a part of that shared information, we call it, and that's called the BIM Service Center. So the BIM Service Center basically is a one-stop shop for all our specialized applications, like the ones we're going to be using today, where we can design different models and enable the BIM functionality here. Now, all these specialized applications you can see are able to generate technical documents, and those technical documents, such as specifications, cost estimates, etc., are able to be shared on the platform as well. So let's quickly have a look. We'll get into the software just in a bit. We'll just go through this a little bit. So this is the BIM Service Center. I'm going to log in using my account. Now you guys can, of course, make your own account quite easily just by pressing here, register here. You'll be asked to confirm an email, and basically once you confirm the email, you have access to the store here, and that's what we're going to be looking at. But just quickly about the demonstration about the model. So this is a project. Let's have a look. So this is the projects tab here, where I can view the different projects that I'm a part of. Let's have a look at this one. This is the Crown Hall Myers project, a European initiative where we're looking at energy behavior and multiple things where we can do to reduce our footprint. You can see this is the project dashboard. Now, what I want to explain is the ability to use different specialized applications in conjunction with the physical 3D model to create a project. And you can see here, if I come over here, I have the different models that are associated with this project, the Crown Hall Myers. Maybe I'll just open it full screen. And you can see here, this is my structural model. So you can see all my foundations, my beams, and things such as that. I can turn off my structural model and just view my architectural model. So this model has been created in IFC Builder, and as you can see, we get the fundamental aspects. So columns, walls, partitions, slabs, etc. And then of course, we can look at all the different models that we've associated with this project. So we've got our furniture model, our water equipment, our structural model, as I mentioned, our carpentry, so our windows and things such as that, our lighting model as well with our CYPECAD program, plumbing as well, and the list goes on. And all these specialized applications can be found on the store. And you can see here, I can search by category. As I mentioned, this is the 3D architectural model generator, and it's free to use here. So that's easily downloadable as well. Now, that's a bit about the BIM Service Center. Now, of course, you can search by categories here if you'd like. We also have our structural programs here as well. So that's a little bit about the workflow. I'm going to go into our program now. And the first one we're going to be using is CYPECAD. And CYPECAD is a program that we use to carry out the analysis and design of reinforced concrete and steel structures subject to horizontal and vertical forces. So for houses, buildings, and also civil work projects as well. So let's open that up. By the way, if you guys had any questions, don't be just ask them. And if it's an answer that won't require too much time, I'll answer it immediately. But if not, we can go through them at the end of the presentation. So this is CYPECAD, the program I just mentioned. Now, of course, this is BIM enabled, so I've logged into my BIM account here, my BIM Service Center account here, and now I've made the connection, that connection that I mentioned before with the BIM Service Center and also my application here, and that's done through the synchronizer that I have. So there are multiple different ways to start. If you guys have just downloaded the program, I would encourage you guys to look at the examples provided, where you can get some inspiration and things like that as well. There's also our file manager, where we can import projects that have been shared from other stakeholders and friends as well. But in this presentation, I'm going to be creating a new job. Now, when I create a new job, I can create a file, example, webinar 502. And now the project, the program asks me whether I want to import a BIM model. Now, what this basically means is the project is asking whether I want to import a architectural model. Now, that can be useful when we have an architectural model and we want to create the structural model here. But for this example, I'm going to select no. Then once I've selected that I'm not going to be using a architectural model to make my structure, I have different options of how I want to model. And this is one of the great features about CYPECAD, is that we accommodate the multiple different ways of modeling your structure. So we've got one option is to import a job from Cype 3D. Now, Cype 3D is our steel structures a solution where we can design steel structures in their own solution, but also there is that interoperability with our concrete structures program as well. As you can see, I'm able to import the program. We can also introduce DXF and DWG files, and the program will intelligently generate different aspects of the building according to the drawing that we introduce. So things such as columns, floors, as you can see here by reading the description, columns, floors, edge beams, and internal openings. So basically the different facades and things as well. We can also introduce a IFC file format here. So if we had, so again, as I mentioned, different files coming from other specialized applications, we can use our plugins or a native IFC file to introduce that into the program as well. And then we also have some other example options where we can, where the program will guide you through the steps of modeling. Now, for this purpose, I'm going to create an empty job. So we're sticking to the basics here. And now I get the general data tab. Now, this is something that can be configured along the way as well, but usually we would do it before. You can see the program has adopted multiple different codes from around the world. You can see now we're here currently in Europe, so I've adopted the Euro codes to, across a wide range of aspects. So concrete, cold form steel, and you can see all the different codes present that we've imported into our workflow. So then again, we have, of course, different options for our specifications for concrete, steel, our sections as well. We can also introduce loading here as well prior to beginning the job. So wind loading, seismic loading, all our wind load specifications come from the selected code as well. And also things such as effective length factors and environment as well. I'm just going to keep them as default. Let's accept. We can also create some snow bearing pressures and displacements. That's fine. We can accept. And now we are at the initial work environment. So you can see here the different pages that are present here. I have the column definition page. I have the beam definition page. I have my results after I've analyzed it, and then I can look at the contour maps, the form shapes, and also some health and safety factors as well. So what I'm going to do is I'm going to create a little basic project where we can look at the different ways of modeling the project. So let's get started. Now we've selected the code we want to use. What I'm going to do is I'm going to go to introduction. I'm going to go to floors and groups, and I'm going to create my floors. I'm going to select it single. I'm going to select 2 floors with a height of 3 meters each. I can also introduce some live loads and dead loads here as well. So 3, just as an example, and I can accept that change. Now, at this point, we have the structure of the floors, but we don't have the template. So what I can do now is create some templates. So let's go to introduction. Let's go to this button here. So this is edit templates, where I can bring up my templates view manager. Now the templates view manager, what it allows us to do is bring in DWG and DXF files, of course, and bring those in to the specific floor groups as well. So I'm going to select this. I'm going to bring in this one offices template that I have. And you can see that that's been introduced. Now there are different editing functions with the templates I can use. So I can select the visible area of the template and change that. I can change different scales and rotation as well, the visible areas as well. So I can have a look and just change the visible area of the template. I can also assign different group views. So as you can see here, my different groups, as you can see, my foundations, floor 1, floor 2, and my column definition, I can just select all of them for the sake of this demonstration to that one drawing. I can also look at different layers as well, and things such as that nature as well. So let's accept the changes here, and as you can see now, the template has been inserted here. Now, of course, we can also define different templates to different sections of the building as well, and that's another functionality here we have as well. Now, we can start off by adding a new column. So let's do that by this button here, new column. And here we have our new column views template. So I can reference the different column. I'm able to choose the initial group and last group. We're going to keep it as that. I can define the different fixities and also the angle as well. So there are some effective lengths we can define, fixity coefficients, etc., etc. What I'm going to do is just have a look at the different columns that we can use. So here you can see the different materials. So steel, timber, composite sections, and also the generic sections as well. I can also define the shape as well, and I can go into specific sections and create my own shape as well. So we're going to stick to a typical structure. I'm going to keep it as 30, and let's say 45, and let's accept those changes. Now you can see as well the 2D view is able to give me a section view of the column, and also the floors that the column exists in as well. So let's accept those changes. And now I'm ready to add my columns. So what I want to do now is head over to my template object snaps. So what this basically does is gives me the option, gives me actually various options of how I want my cursor to interact with the template. So what I'm going to do is I'm going to select all of them, except the nearest option. Now I'm able to insert my columns in various locations. As easy as this. So I'm using my left button to insert columns here. Now, of course, I'll be able to edit these columns at a later date, at a later time, sorry. As well. As you can see, those columns have been introduced. I can right click to select to define those. And now I have the option to move and edit the columns as well here. So we can go to introduction, we can go to columns, and you can see all here the different options I have to define the positioning here. So I can adjust. So I can adjust it to the corner. As such. Now, once that's done, we can of course copy and define different external fixities and horizontal loads, head loads as well, that we can define here. Now, I'm not going to do that. I'm going to continue on so we can look at some analysis. I want to get into the analysis section as well. We also have the possibility to change different column types. So if we had specific columns that we wanted to change, I'd head over to edit, and I also am able to edit the column individually as well. Now, as you can see, I've moved the columns to the appropriate positions and adjusted the positioning. Now you can see we can move on to our beam definitions. So after we've defined the column, now of course this is a very simple structure that I've defined, but let's move on to our beam definition. Andreas has said that there is no sound. Can you guys please confirm if you guys hear me or not? I know at the start of the presentation I did get some comments that the quality was good. If you guys can please please let me know. Okay, Lamia says I can hear you. Andreas, can you please maybe check your connection because there are other people in the presentation. Yeah, okay. Okay, Andreas, I think you might need to check your speaker. Now, let's move on. What we can do? Let's move on to our beam definition, as I said. Sorry. Now, we can have a look at some foundations as well. Okay, perfect. Thanks, Andreas. Now, initially, what I want to do is create some foundations. So I'll go into my bottom level. You can see what we can do is generate some footings and beams as well. So we can have a look. We can automatically generate the footings here by introducing the vision distance of vision angle. We can accept those. And the program will define some footings as well. Now, what I don't want that. Let's go back. I want to delete these. I can go back to generate footings, and I can change the vision distance to 1 meter. And the program will define the footings as such. Now, of course, I can edit those footings as well and design them intelligently. I can also look at the different code checks that have been done on particular footings from the particular code, and you can see that that's been verified as well. Now, that's before we've introduced the loads. Now, let's create some strap and tie beams. So we can go to our beams, we can define them. Now you can see here we have a multitude of different beams we're able to define here. So flat beams, drop beams, etc. And also the type of that particular family of beam. So let's create a drop beam of this here. Let's say 15 and 25. And now I'm able to turn off my snaps and so what I'd want to do is go back and edit my my columns now to change the positioning. So again, introduction, columns, adjust. As well. Okay, so let's go back to beam definition. Beams, define beam. And what I can do as well is I can go back to columns. So as you can see, I can move around quite easily to define different types of beams and columns as well. So we can add a new column here. And I can define the structure of the column as well. And accept those changes. Back to beam definition. Now I can also add another one here. So what I'm trying to demonstrate here is the ease of working across different functions, and also just the ease of editing, and also defining the different columns and foundation elements as well. From time to time, we can also adjust our walls as well. So of course, we have the different options to adjust the walls depending on the particular thing. Now, as you can see, I haven't, because we're limited to time, I won't actually go into particular aspects and define them. But as you can see, I can define the wall depending on the template, and also my preferences as well, as such. Now, we can also go into our 3D view, and as you can see, we've got our structure able to view in three dimensions as well. Now, let's move on. We can move up a level now. And create our beams again. Of course, if we wanted to, we can go back and also introduce our slabs as well. So here we have our panel manager. We can select define panel, and here we have the different options for our panels. So joint floor slabs, hollow core slabs, composite slabs, and we can define the different depths and define the panel to a certain beam. We can copy that panel and copy the different elements from that panel and define them to other panels as well. Now, of course, we can create our beams here on this level as well. And accept those changes. So Daniel just asked a question. If the beam positions are all the same, yes, we can. So we can go to groups. We can copy from another group. So you can see here, I can copy the columns from floor 1 to floor 2 as well. So I'm just, of course, there is that functionality there as well. Now, of course, if we want to introduce stairs sections as well, we also have our stairs generator here. So what I'd need to do, we could go back down. Now, of course, we don't have the beam here, but I can go up. I can create a different beam. My fictitious slab here. Go to slabs and introduce an opening at that particular section, or go to slab, panel manager, and delete this panel here, and there I'm able to create a definition of stairs here as well. Now the stair generator, of course, we have some default stairs that we can use as well. So I can create this one, so stair 1. Defining the different widths of the stairs, the rotation, whether we want it to go right or left, the loads as well, so the load combinations with the stairs, and also the spans. So I can we have some different types of stairs, but we can also go into our creation manager and create our different types of stairs as well here to define them. So we can do one. We can also introduce depths of the flat slab as well, and the starting difference. So if I were to tick this depth of flat slab, the program would not automatically define the depth. So we can also, you can see here the functionality with our with the ability to customize the different options and also work with the program to define certain sections as well. Now I can of course insert the stairs and then choose the orthogonality tool to get them at right angles. And then of course, once that's done, I can move the stairs as well to the required position that I'd like. Now, we can then consult the template, and you can see now I have to introduce a opening within the top slab as well. So I can go up. I can then create my other beam. And delete that section. Now, of course, I'd have to do some more adjusting, but we're strict for time now, so that's just a bit about the functionality with the stairs. So quite intuitive in the way that we can customize them to a high degree, and things such as that as well. Now, notice we can also generate the loads from the stairs as well. So not only are we able to customize the geometry of the stairs, but also we're able to toggle on or off the transfer of loads from them as well. Now, if we want, we can go back to our general data. What we can do now, just before I do that, is analyze so we can see here we've got 0 to 11 and 6 to 10 to 5. Okay, so what I want to do now is introduce some wind loads as well. So you can see I can head over to the general data tab, introduce the wind loads here. Now, of course, our wind and seismic loads all come from specific countries and wind load codes. You can see here the list of different codes that we've adopted. Now, of course, there are different specifications from multiple different codes that we'd like to use. Let's use the British standard here. I can change this tributary length from 20 to 25 if I want to. I can also define the tributary widths by widths as well. And as you can see, that's been done. Now then we can move on to our loads. So I can introduce a plethora of different loads here. You can see point, line, and surface loads, and also the option to create uniform or trapezoid loads as well. I can also introduce different load cases that will be present in the analysis as well there. So temperature, shrinkage, wind loads, snow loads, earthquake, and accidental loads as well. Now let's accept. And we can now analyze the project. Now, of course, there will be a lot of errors here because we haven't obviously done it correctly, but what I want to do is just demonstrate the functionality here. You can see here, after the analysis has been done, I get a incidents report as well. Now these incidents reports can be shared with different stakeholders of the project. I can also export them in different formats as well and print them as well. Now, as you can see, the project's been analyzed. I can go into the results tab and we can consult some different reports as well. So here we're able to create some, look at some beam errors and things such as that as well. Now we can have a look. You can see here the different options that we have with. It doesn't seem to have analyzed. Go back, including foundations. Let's have a look. Okay. So I haven't. Let's introduce some slabs here. Let's run the analysis again. Now here you can see that I'm able to, after doing the analysis, design again the different foundations as well, and also different elements from the structure. Now I can create some different views as well, so reinforcement views from the slab. As well. So that's right, that's what I've done wrong. So let's delete these. And we can go back to the analyze. Okay, perfect. My bad. I've just confused the floors here. So we can just give it a minute for the analysis to occur. Okay, so again, we have the error document. We can now see that the program has defined, intelligently designed different aspects of it, different aspects of our installation. Now we can head over to results, and you can see here, now I'm able to look at the editing of different columns and shear walls, beams as well, our flat slabs, joints, our composite slabs, and as well, and the list goes on. So we can have a look at our the editing of different columns. And you can see here now our columns editor appears. Now you can see here, I have the option to redesign group reinforcements and also view the different checks and detailing from those columns. You can see here as well the list of columns and also our column schedule here. So I can move on to different bays, and as well the sections and positionings of those columns are present here. So the program intelligently groups different columns corresponding to their function, and also I can do that manually as well. So you can see here the particular column, the floors that it exists in, and here I can edit the different types of reinforcement depending on the checks that have been done here as well. You can see here at the bottom as well the summary of those code checks. So the real loads and our use percentage as well, with also the different combinations that are present as within that particular column as well. I can also come over here to the checks and get a complete report on the checks considered on that column, with the different references as well. So you can see here all these different checks can be shared, exported, and as well. I can also view the complete listing as well, so get a complete report on that particular column. Now, we can, of course, move on from here. I can also get a 3D view of particular columns as well. We can have a look. Let me change the background here. And I can get a 3D view of that particular column along with the reinforcement present in it as well. I can also look at the particular forces present in that column, and also define the visibilities here as well with my different values. So again, what this basically demonstrates is that we can also work on a larger scale with a multitude of columns, but then we can also look at particular aspects and checks from one single column as well. Now let's move up. Now you can see here the different checks that have been done on my beams, and you can see here in red, these are the beams that haven't satisfied the conditions. So I can go to beam, I can go to our beam editor here. So here you can see our beam editor. Now here you can see the different views present from that beam. So the group the groups that it exists in, and also the frame or the bay that the beam is a part of. I can also toggle the different views from my forces and create those on our diagram here. The most important part here is the reinforcement area graphs. You can see here the required total reinforcement in red, and also the supplied total area in green. So when we're dealing with different changes that we introduce to our beams, those can easily be consulted with this view here. Now, of course, we can look at the different errors that have been present within the program as well. So as you can see, I can get a overview of the different areas. I can also go here into our different checks at the worst case scenario. So this is where we can look at the worst case scenario here. And again, we have the option to only show the checks that have failed. And so these are all the checks that have failed on this particular beam. And again, be able to view the complete listing here. So what this basically does is we're able to reference the code and investigate why particular things have failed, and then go back into our view here and consult and make changes to the beam. Now, of course, I can introduce different reinforcements here as well using our longitudinal reinforcement section. I can also introduce transverse reinforcement, of course, and toggle the different reinforcement areas. So here you can see now I'm viewing my longitudinal reinforcement, and then I can view my transverse reinforcement. So basically a one-stop shop here, looking at the different characteristics and behavior of our beams. Now we can head over to our slabs. Now, of course, these are the different options I can use to modify the reinforcement in our slabs. And you can see here a multitude of different options to define the reinforcement within our slabs as well. Now, of course, another feature that I wanted to touch on was the implementation of the 3D structures we're able to do here. So not only are we able to define concrete reinforcement structures, but we're also able to insert new 3D structures as well within this program. You can see here I'm able to create a new structure and define different nodes and points where we can define and introduce a 3D structure such as a shed or things like that as well. Again, we can define and view in real time the forces within the beam as well, and also the forces within the columns as well, as I mentioned prior. Now, that's a little bit about our CYPECAD structure. We can move on to our contour maps as well and find the define the different load cases that we've introduced prior, and look at the behavior of that as well. So a multitude of different viewing options of our results can be defined here. We can also look at the different loads that are present. As you can see here, my stair loads, I can make those available here, as well as design forces with a multitude of different variations here. So that's a bit about our contour maps as well, and then we can move on to our our deformed shape. So looking at the different load cases that I've defined, and also the different combinations of loads, and I'm able to view those here as well. I can also create animations with those loads, and also being able to toggle the views within that as well. I can also view the structure and also the waffle slabs as well. As such. So that's a basic overview of CYPECAD. And so if I've demonstrated it correctly, what I wanted to demonstrate in this very quick presentation on it, it's quite a complex, it's quite a dense, a dense software in terms of its capabilities. What I wanted to demonstrate is the ease of workflow from column definition all the way to deform shape and health and safety, where we can make changes along the way and produce some great reports and also some great template viewing options as well. And not only that, but also our different editing tools for our columns, our beams, our slabs as well. Now, of course, we can generate the different reports from our project. So a large number of different reports, as you can see here. We can have a look at our job data report. I can create different chaptering and indexes as well. So these are our reports that we can generate quite easily here. Not only reports, again, I'm just going to go through one of them, not only reports, but also drawings as well. So the different drawings that we can generate from our design. So detail level columns, floor plans, all the way to our stairs definition. So we can here choose detail level columns. I can also select multiple details. Again, I have the option to configure all these different reports to a very high degree. Let's just keep it at that. And you can see, as easy as that, I'm able to define, I'm able to generate the different reports here as well. So you can see in my column schedule, along with the different reinforcements that are present as well. Again, these can all be saved and printed and shared with project collaborators as well. And these are my beams as well. Now that's a little bit about the CYPECAD. Now, of course, there are plenty of other features that we have that I haven't been able to go through in this report, in this presentation, because we have to move on to our box culverts program, in which I'll touch on as well. But of course, the functionality is here. We have a very easy to use environment where we can define and analyze the concrete structures of our project. Now let's move on. Lamy has asked, can we work in 3D view instead of working in the 2D view to get a 3D? Yes, we can. So again, when we're in our results tab, we can also work in a 3D view alongside the 2D view, and that's basically the premise of our workflow. We have our 3D view that accompanies our 2D work environment, and where it complements it great in that way. Okay, so moving on to our box culverts. Now, box culverts, of course, we have our own specialist program for designing and analyzing of box culverts. Let's get started. I'm going to create a new project. Now, here you can see we've implemented a assistant for creating new projects. You can see here we have an assistant for straight culverts, assistant for skewed culverts, and for general culverts as well. So let's create a straight culvert with the assistant. And as you can see here, the assistant basically asks us the different geometries and specifications that surround the environment of our box culvert. So here you can see, let's change this to 5, and let's make that 6 meters. We can amend our wing walls again, and also introduce a degree, an angle that the wing walls will portray. We can also define the top roadway within the culvert, on top of the culvert. So here you can see the axis coordinates, and you can see here the diagram that represents the different values that you have to insert. So again, let's change this to 20 degrees so that we have a bit of an angle. The width is 5 meters, basically the average road length, and the height above the floor slab you can see is 6 meters. Now we can go back and see that the height of our thing was, our G was 5 meters, so I'd have to, just for safety, make this about 8 meters for the height above the floor slab. Then we can also introduce our soils. Now we can do this at a later date as well, but here we'd have to work with our different, the different values we get from the soil tests. So let's have loose sand, let's have dense sand at the bottom and then loose sand at the top, with an average slope angle of 26. No worries. And then our loads. So we can generate the different loads from particular standards that we have here. So of course, let's just keep it as the IAP 98 with a general surcharge at the bottom of the slab. So here we can look at the different uses of our box culvert and introduce the surcharge that'll be present at the bottom. I'm going to keep it as 4 kilonewtons. Yeah, that's all right. So here we get the information of our slab report, and then we get, oh sorry, I should have selected accept. And you can see here, the program generates the box culvert automatically. To start off with, I can consult it in my 3D view. You can see here this particular plane demonstrating the roadway as well. So here you can see a basic, and this is what I want to demonstrate, the basic work environment that we work with. Of course the 2D view, but also the functionality with the 3D view, being able to complement our design simultaneously. So, and of course, with our 3D view, we're able to toggle on or off the different background colors, different views, rotations, with different viewing options as well. Now, there are different editing tools as well. So we can go into our general options, and now I can define the subgrade modulus and also my soil characteristics to a greater degree here as well. So introducing soil friction factors, allowable bearing pressures. Also, I can insert the fill that's going to be present when during construction, and also some loads that I can introduce here as well. We can also look at the different options when we go to analyze. So minimum compliance percentages for slabs, the option to allow the program to design the wing footings as well. They go towards the backfill and also towards the infill as well. We can also look at some reinforcement tables as well. So looking at the different reinforcements within the structure, and being able to change the admissible diameters and spacings as well, all to your preference. Now, of course, we can edit the different walls and lateral points that we have here using our plan tab. We can also create different levels within the structure as well. We can edit the geometry here. So you can see here, if I wanted to create a split within the halfway through the structure, I'm able to do that. I can create this and say from perpendicular to the left wall, thickness of 20. We can accept that, and you can see here the program is able to insert that spacer there. I can also introduce truck loads as well. So the different loads combinations I'm able to use, and you can see here I can edit the truck load as well. So looking at the overall shape of this truck and the option to edit different coordinates for the tires and wheels. I can also introduce strip loads. As you can see, the truck already generates the particular strip load, but I can edit that as well if I want to. And I can now create and do some analysis with the job. So I can check the job initially. Okay, so I need to define the reinforcement. And you can see here, I can view my reinforcement tables. Oh. Sorry, redesign my reinforcement as well. And also get a view of the different reinforcements here as well. We can also have a look at some different examples that are present within the project as well. So have some idea of the different options and a wide variety of different culverts we can design. So a simple culvert as such. You can see here the different geometries as well that we're able to insert. So looking at quite complex culverts here with different purposes, rail as well that go over the culvert as such as well. Here you can see a combination of 3 different culverts that have been combined to produce one overall smooth culvert with a water load as well that we've introduced here. Here you can see as well the same sort of structure that we have with CYPECAD, the ability to look at our results and our deformed shapes as well. So I can introduce maximum values as well. I can view the actual structure alongside the analysis results and define the different load cases. So again, my hydraulic surcharge that's present with this project, I'm able to view that as well. And you can see here in red the hydraulic surcharge, the concentration. And also with the contour maps as well. So looking at displacements, forces within the structure, and again being able to define maximum and minimum values for those pressures. You can see here the earth pressure as well on the side of the culvert. Sorry. I can also look at and consult the different forces at particular sections of the culvert. So the different displacements as well. I can view those instantaneously as well. Again, a great functionality here is the ability to generate some complete reports. So here you can see the different options within my report. I'm able to generate those as well. So you can see here an index of all the different aspects within the report, and then a breakdown by wing, by element of the different hydraulic surcharges, earth pressures, and all our forces that are present within the structure. So as you can see here, quite a dense report defining and analyzing with the analysis of that of our box culvert. Again, we have the option to generate our drawings as well. So here you can see the different customization options for our drawings. And I can view the different detailing within within the drawing. So overall view, different sections of our wings with different views as well, and also our reinforcement schedules. Now, of course, this is all condensed to one basic A0 plan, but then we can, of course, edit and move different objects and also create new drawings within it as well. And so that's basically the different options we can do for creating and also distributing the different our different options for our box culverts. Now, of course, there are different ways to edit our different elements within the slab, as I mentioned before. But that's basically how intuitive the program is in accommodating the different requirements that our engineers need. So in terms of modeling the different environment around your structure, it's quite easy. As you can see, we can define the different soil charges, different modules within the structure, and I can view all the different reinforcement options as well within each module. Of course, I can edit different reinforcement all within the program as well. I can, of course, print and complete the drawings of this particular section if I wanted to as well. Now that's a little bit about our basic workflow. So that was CYPECAD and box culverts. If you guys had any questions, I will be taking those now, where we can. I'll try to introduce. I'll try to best answer those questions regarding our solutions. Now I know that we went through these softwares quite quickly. Now, of course, these are quite technical structures here. So a more in-depth analysis, if you guys are more interested, we can of course go through particular aspects about these programs, such as column definition or different use cases for the interoperability with the BIM workflow. That can all be done here as well. We can of course accommodate. Now Lamia asks, can we import from Tekla or Revit? Now yes, we can have a look. We can have a look here. Within our CYPECAD structure, you can see I have a import button here. I'm able to import a Tekla structure here, Lamia. So that can be inserted here as well. And I can bring in our different structures. Now, in terms of our Revit, we have already we've actually designed our own Revit plugin that we can see here, and you can see here our plugin, Revit plugin here that we've created individually for Revit. Now, of course, we also have our IFC uploader here, where we can import structures from Tekla using our IFC uploader as well. So in terms of functionality, again, as I mentioned initially, we have different options to introduce those structures here as well. So we have multiple different options that cater for a wide range of from a wide range of different solutions that other people have. So I hope that's answered your question as well. Yes, we can, of course. Krishnamurthy asked a more detailed question regarding a particular problem he's had. Krishnamurthy, we can actually go into your problem more in depth, not particularly in this webinar, because we're just doing an overview of of the workflow. But because you have a specific problem that you've used the program already with, we can have a look at providing a solution for you as well. I will email you a solution for that particular problem. No worries. Okay, guys, I think that's all the questions we've had. Now, again, if you guys would like to schedule another presentation where you want to go through particular aspects within the program, we can accommodate that as well with you guys as well. All right. I hope you guys enjoyed the webinar. Again, it's just a brief overview of the two programs we have, be sure to check out next week's webinar where we'll be looking at our steel structures solutions. All right, guys. Have a great day. No worries. Thank you. Bye.